All right. So basically, the question tells us two things. That it is giving us this sine of theta is equal to 15 over 17, and it is in the second quadrant. Now, what can we learn from this? All right. So basically, with these quadrants, which one is the second one? That would be this one, right? So we know that the triangle is somewhere there. Not the triangle, the terminal arm. Okay? So it tells us that the terminal arm is somewhere in that quadrant. Okay? I'm sure you learned that. Now, how can we get that from the information we're given, right? So now I want you to think so, ka, toa, right? Say you're given a triangle, right? And you have sine of theta, and this is going to be theta, is equal to 15 over 17, right? So what, that triangle sucks. Let me redraw it. Okay, so what can we know from this? Okay, so sine of theta is equal to 15 over 17. Well, with SOHCAHTOA, as in this, we know that this is opposite, this is hypotenuse, right? I don't think I spelled that right, and I don't care. Okay, so we know that this is equal to opposite over hypotenuse, right? So now which one is the opposite of theta, right? It'd be this one. So we know that this is going to be 15, and hypotenuse, what's that? That is going to be 17. Now we're just going to use that logic and apply that here, right? So first of all, why don't we draw a terminal arm in this quadrant? So basically a terminal arm is like basically just like it can be anywhere. It can be like here or it can be like here. It's just like anywhere. But we know that it is in the second quadrant, so that's why we're putting it there, right? Hopefully that's clear. So now we have the terminal arm, right? Let me look at the question again. Okay, standard position. All right, that's fine. So now, why don't we draw a right triangle? I'm going to use this angle right here because it is called a reference angle. Okay? A reference angle is equal to the angle attached to x-axis. Now, this is the x-axis. Now, I could technically draw a triangle from like out here too, but that wouldn't make sense, would it? Because I'm trying to use this reference angle. So that's why I'm going to draw that triangle over here. Okay? So I just drew my terminal arm. Okay? This is my terminal arm. Now I need to figure out. Wait, actually, what was the question again? Holy moly. Alright, solve for cosine and solve for sine. Alright, wait. No, never mind. Just solve for the exact values of the other two primary trigonometry. Okay, so we do have sine x. Now we're trying to solve for cosine x or tan x, right? Those are the two things we're trying to solve for. So how can we do that, right? So now this triangle here, we know that sine of x, I'm just going to call theta x, okay? I'm used to that, is equal to 15 over 17, right? And with SOHCAHTOA, we know that it's opposite over hypotenuse. So opposite over hypotenuse. 15, I'll just erase that, 15 over 17. All right? Now, how can we calculate this thing here? As you can see, we formed a triangle. Now we're going to try to calculate this bottom here. Now, we know that it is a right triangle, okay? So now we can go back to our handy little brain and go back to grade 8, I think. So we're going to use Pythagorean theorem, right? So we know that a squared plus b squared is equal to c squared. So what are you not given? You are given the hypotenuse, you're given one of the lengths, you're trying to find the other length, right? So we're going to basically solve for a. Okay, so a squared, you know what? I can trust that you can do that on your own. Okay. I have my calculator out. 17 squared minus 15 squared. Root of that. That's 8. A is equal to 8. Okay? Now this is going to be our bottom length here. Now that we have all the sides, we can solve for cosine and tan, right? So we know that if we go back to SOHCAHTOA, we're going to go to the ka part, right? Now I want you to focus on adjacent and hypotenuse, okay? So which one is adjacent in this triangle? Which one is hypotenuse, right? So if this is our angle right here, the adjacent one is 8 and the hypotenuse is 17. All right? So cosine x is equal to adjacent, which is 8 over 17. Same for tangent, right? Tangent of x is equal to OA, right? Opposite over adjacent, right? Opposite, if you go from this angle right here, opposite over adjacent, right? That's going to be 15 over 8. And yeah, that's pretty much it, I think.